Just a disclaimer, this video is not meant to be a tutorial for solving the 3x3 Rubik's Cube. I do have tutorials on that over here, but this video is basically just a little bit of a fun if you're bored one day and decide to do this. So one day I was fiddling with the Rubik's Cube, and just for fun I decided to try solve it using only double moves apart from the U and D layers. So what I did is I scrambled it up, and it looks something like this. And I see if I could, and I decided, hey, why not try to solve this with using only double moves, but I can turn the up and down layers however many times I want. So, in this video, I'm going to show you how to solve it like this. Just something that I'd like to point out, if you do this, you always get the bottom and the top layers the same color, so white and yellow on the top and bottom. So that essentially means this actually operates really similarly to a square one. On a square one, you can only turn the right side 180 degrees, and you can turn the up and bottom layers any amount of times. You can't do like front and back kind of stuff, but it's still pretty close. So the method I'll be using to solve this like this is actually really similar to how you'd solve the square one. So if you do know square one, I'm not saying that you need to know square one to know how to do this, but it will help a little bit. So yeah, when you do scramble a square one, you can see that the bottom is all white and yellow. This one does shapeshift though, so it's a little bit more complicated. So let's get started. So the first step is to get the middle layer solved. So preferably you'd want to hold it like this, something like that, and basically only using the standing right, front, left and back layers, you want to solve kind of the middle part. Now this is like really easy and it really shouldn't need any explanation. You can pretty much solve this middle bar intuitively. Now here's the bit where I say it's pretty similar to square one. So what we need to do is we are going to orient all the edges, so get all the yellow edges on this side because it's yellow center and the white edges down here. So what you want to do is on the bottom, find an edge that you do not want. So say this one, this is a yellow edge and we don't want it here because it's a white edge here. Now on the top, you line two of the edges up, so it's yellow here. You want to find the correct edge on the top, which will be the same color as this one. And then what you want to do is you want to bring it up, and then you bring an unsolved edge in here, and then you just put it back down. It's as simple as that. So here it might be easier to see. We have three edges done. This is the wrong one. We don't want this here, so we move it to this place. And then we make sure there's a solved edge on top of it. It will be the same color, so we can bring it up. We move an unsolved edge here, and we put it back down. Okay, now we have CO, so basically what we want to do is we want to get all the corners in the right spot. So it's kind of the same thing. We find a corner that we don't want, say on the top, and say we don't want this one here. We don't want this white one here. Then we look on the bottom, and we find another corner that we don't want there. So this one. These two, we don't want them here. And if you just put them on the right side, we can do this algorithm. It's a really short algorithm though. R2, U, R2, U prime, R2. And that effectively swaps the two corners. Doesn't exactly swap them, but as you can see, they are both oriented. So just repeat that process of getting both of the corners to this kind of front right slot and then do the algorithm. Now the next step is maybe if you might see that this middle layer is kind of ruined. It's kind of off by a half turn, but obviously if you do the half turn, it's off. Then to fix this, now if you do know square one, then this actually be really obvious. You do kind of R2, U2, R2, U2, R2, and that kind of flips this. So what we can do is R2, U2, R2, U2, R2, and then that essentially flips this bar. Next step is CP, where we solve all the corners. So there are actually quite a few cases for this, and we want to essentially boil them down to just this case. This is where you have both sides, they need to swap one corner. one pair of corners. So we have headlights and headlights. And when you have this case, you put this, we're only going to be using one algorithm for this, and it's actually pretty similar to square one if you know this algorithm. And that essentially swaps these two back corners and these two back corners. Don't worry about the edges, we'll get to that a little bit later. But essentially it's R2, U, R2, U prime, D prime, R2, D, R2. And that algorithm, funnily enough, fits by name, it's called JJ. And basically what you can do is, if you put both headlights on the front, you can do the same thing. R2, U, R2, U prime, D prime, R2, D, R2. And the corners are solved. And you can actually do this really fast. So the idea for the other cases is we're going to try to boil them down to just that case. So for this case, where one of the latest corners is solved and the other one is has an adjacent swap, then what you want to do is you want to put the one with an adjacent swap on the left or the right, actually doesn't really matter, and then do the algorithm. And then you'll realize that you have headlights on the front and you have a kind of this here, and then you can do it again. And then you have CP done. If you have, say, a diagonal corner swap on the top and you have an adjacent corner swap on the bottom or the other way around, then it's kind of the same thing. You just hold the one with the adjacent swap on the right or the left, doesn't really matter, and the diagonal swap can be whatever, and then you do the algorithm, and then you have headlights, two pairs of headlights. If you have a case where you have two cases of diagonal corner swap, so diagonal corner swap on the top and bottom, then you just do the algorithm from any angle, and then do kind of U2 D2 to find your headlights, and then do the algorithm again. And if you have solved on one side and diagonal on the other side, then just do the algorithm from any angle, and then you'll have headlights somewhere, and then do the algorithm again. And lastly is EP, or edge permutation, and we are now going to permute all the edges. So firstly, if you see an EP case that you do not recognize, so if this is not like a possible PLO, like what PLO is this, then you have parity, and the parity algorithm is just M2, U2, M2, and that will fix parity. So what we basically want to do is kind of the same thing as last time. We want to just basically get from the all possible combinations and kind of just branch them down into the one ideal case. And actually there are two of them, they're kind of like mirrors of each other. So the ideal cases are when you have two like U-perms, and one of them's going clockwise, so on the top it's going clockwise, and on the bottom it's going... that's wrong. And the other one's going anti-clockwise. So it's basically one's going clockwise and the other is going anti-clockwise. So these are the easiest cases to do. And what we're going to be doing is we're going to be doing kind of another algorithm. It's basically the same as last time, but with one kind of twist. Basically, if you see there's a clockwise on the top and anti-clockwise on the bottom, then what you want to do is you want to do that algorithm from CP from earlier, so that's like this, and then repeat the algorithm, but then just do double layers for R moves, so that would look like this. And you can just correct it and you've solved it. So now if you have anti-clockwise on the top and clockwise on the bottom, what you want to do is actually you want to start the double layers. So you want to start like this and then do the single layer. Okay, when I said we were going to boil all the cases down to just a U-perm, if you see a H-perm, just like a singular H-perm, then what you can do is just the regular H-perm algorithm. And this is actually doing M2s is valid because that's kind of similar to doing L2 and R2 moves. So this is actually valid. And if you see like two H-perms, you can do a H-perm on the top and flip it over, or you could do like this, which is equally valid, I guess. So if you see that if you have two U-perms, but they both go the same way, so this one is an anti-clockwise U-perm and this one is also anti-clockwise, then just do H-perm from any angle and that will automatically make them different. So you can do this one is clockwise, this one's anti-clockwise, so we can do the corresponding algorithm. if you see two Z perms, or Z perms I guess, then what you can do is you can just do the one of the algorithms I taught earlier. So you can do the single layer first or the double layer first, whichever. I'll do single layer, the single layer case, and you'll automatically get two U perms. So if you get a case where you have a H perm and a U perm, then what you want to do is hold it like you're solving the U perm. It doesn't matter how you're solving the H perm, but then if you look at this, it's going anti-clockwise, but you actually want to do the opposite one. So let's just say we're just going to pretend that this goes clockwise, even though this does go anti-clockwise. And what this will do is it will keep this unsolved, but then it will do a U-perm on the bottom, so this translates to a U-perm, and we get a double U-perm. Okay, so this is anti-clockwise, or clockwise as I should say, so we can do the corresponding algorithm. And now we get two U-perms. And the same applies when you have a Z-perm on the bottom and a U-perm, or whatever it is. Then just hold the one, hold on the front, so this is clockwise, so we can do the corresponding algorithm. And we automatically get two U-perms. Now, if you have a Z-perm and solved, then what you do is you do just do any U-perm algorithm, double U-perm algorithm, I should say, and then you have two U-perms. And finally, we have the case where we have solved and just a U-perm. So if you get this case, now you can't just do the regular U-perm algorithm because it actually uses singular M moves, and obviously that is not allowed. So what we can do is we can just put the solved bar on the left. Make sure the U-perm's on the top for this one, will be a lot easier. Then we just look at, is this an anti-clockwise or clockwise? This is anti-clockwise. So we do the algorithm for if it was a double U-perm and it was anti-clockwise on the top. So if this is anti-clockwise on the top, then we would do this. But just make sure to hold the bar on the left. It would look like this. And then that would create another U-perm, but then unsolves this at the same time. So we get double U-perm, and this is a nice case. So this is anti-clockwise, and this is actually also anti-clockwise from the H-perm. And this should be straightforward. Now I'm just going to do an example solve so you can really understand what I mean. So I'm just going to scramble it. Alright, so the first step is to fix the middle layer, so this is really intuitive. Okay, now, I got a checkerboard pattern. Actually, for this checkerboard pattern, what you can do is you can just do this and this. But for the sake of simplicity, I'm just going to do the traditional way. So yellow, that would be like that. Yellow, that would be like that. And yellow, that would be like that. Okay, now we fix all the corners. So this and this. Okay, now we do CP. So it looks like we have a diagonal swap on the top, and we have adjacent swap on the bottom. So we hold this on the left and do the algorithm, and then we should have adjacent swap. Okay, looks like we do have parity. If you have parity on one side, then you know you have parity on the other side, so you can do M2 to M2. Okay, now we get a U-perm with a Z-perm on the bottom. So what we can do is just I think it's like unsolve this one, and just this will go clockwise. Let's say this needs to go clockwise, so we can just do this and create another U-perm. And so this goes anti-clockwise. I mean, this goes clockwise. This goes anti-clockwise. So clockwise on the top, we can just do this. Oops. And we're done. Thanks for watching this video. If you actually want to do some solves on this, then upload your solves with the hashtag, I don't know, square1 on a 3x3, and then I might do like a part 2 just reacting to your solves. See how fast this method can get. I'm not going to time it myself, but I don't know, maybe for that video, that might be like a future video. I might do it on my channel, but that's kind of it for this video, and see you next time.